How are you guys? My name is Mr. Exacti, your online teacher, your online tutor. Thank you for liking. Always make sure that when you're following us, make sure you subscribe. Very soon I will hide some of the tutorials for those who are not subscribing. I'll simply adjust the settings of my account. Only the one to view is the one who is my subscriber. So subscribe before it is too late. Now let's talk about simple proportion and scale. Simple proportion is one of the most important skills that we use in mathematics. Why it is important? We apply it in different scenarios to handle mathematical problems. So after simple proportion, I'm going to talk about scale and maybe a little bit of ratios. It's part of your maths exams. It's very important. So get settled and follow us. Look what we do closely. Simple proportion. For instance, number A, you are given that it takes 2 hours to walk a distance of 20 kilometers. How long will it take to walk a distance of 40 kilometers? In a simple proportion, you'll be given 2 sets of data. One set will be complete and the other will be incomplete. We are presented with the time versus distance, time versus distance. But in all sets, distance is given. So you start with the distance. That is, if 20 kilometers takes us 2 hours, then 40 kilometers will take us more than 2 hours or less. If 20 kilometers require 2 hours, on a normal setup, walking 40 kilometers will require actually more hours than this. You compare similar units on their own side, distance, then time. So if you want to get a more answer, among these units you get to put the bigger number on the numerator. That is 40 over 20 multiplied by 2 hours. Then you simplify 2 here, 2 into 2, 1, you will get it then after 4 hours. We call it simple proportion. It's very simple and very important. Let me present one for Excel. It requires 4 kgs of flour to bake 200 scones. How many scones will be baked? From 1 kg of flour. Alright. Such a problem can be handled easily using simple proportion. We are given quantities of flour versus number of scones, but in both setups, the quantity of flour is given. So start with the quantity of flour. That is, if 4 kgs can give us 200 scones, then how about 1 kg? 1 kg will give us more than 200 scones or less. Under the normal setup, then you can say if 4 kgs can give us 200 scones, then 1 kg, from 1 kg we can have less or fewer number of scones. If you need a less answer, among these two less number with the numerator, 1 over 4 times 200 scones. Then 4, 1, 4 into 25, we get 50 scones. And that's the answer. Alright. Then this scenario, it also demands your logic. You must be involved mentally to reason clearly before you start your rush to work. Let's say 2 men, or let's say 8 men take 2 hours to weed a garden. 8 men take 2 hours to weed a garden. How long will it take for 6 men to weed the same garden at the same pace? Logic is important. You need to be involved there mentally and reason with the question. We are given number of men versus time, number of men versus time. 8 men are taking 2 hours to weed a garden. So how long will it take for 6 men? It's not always when we have a smaller number, then the reasoning will say it's less. In this case, it's work. So when you are working in fewer numbers, you will take more time than when you are working in large numbers, you take less time. So if 8 men take 2 hours, 6 men will take more. Because this is now work, you take more time. So since we need the more number, the bigger number will be the numerator, 8 over 6. Then you multiply by 2. That's how you get the number of hours. That is 6, 2 into 2, 1, 2 into 6, 3. 3 into 8, we get 2 in 6, remainder 2 over 3 hours. That's a simple proportion for you. So what to incorporate this skill in solving scale problems. So I'm moving on to scale. Scale. We always come across a scale in most of aspects of our day-to-day living. We use scale to make things big, to magnify, or to make things smaller. Just like how you find yourself framed by a cell phone on a photo, but still looking exactly the way you are. That's scale. Scale is used to make things bigger, to magnify, or to make things smaller, to diminish. And also in maths, in geography, in military, in the surveying, we use scales on maps. For instance, scale on the map is 1 is to 200,000. What's the meaning of this scale? The scale which is reading 1 is to 200,000 means that if units are not specified, they are both in centimeters. 1 centimeters on the map is representing 200,000 on the actual ground. For instance, if this chalkboard was a map, if I draw a line which is 1 centimeter long, map is between 2 bridges, bridge A and bridge B. On the map, they are 1 centimeters apart. It means you go there physically on the actual ground, you measure 200,000 centimeters. So if units are not specified, it means they are both in centimeters. So in most examination situations, we will be required to express actual lengths in kilometers. So what you do first is, before you end with the questions to do with the scale, you do better convert the ground length from centimeters into kilometers. That is, if 1 centimeter is 200,000 centimeters, we want to reduce this one or convert this one to kilometers. But 1 kilometer, yes, 100,000 centimeters. So you divide this one by 100,000 centimeters. So it becomes kilometer like this. Now, it's still the same scale. 1 centimeter is representing 2 kilometers. That way. You always divide the ground length by 100,000 if you want to work with the centimeters and kilometers. Then the questions will be like, find actual length in kilometers of a road which is 8 centimeters on map. A road on a map is 8 centimeters like this. How about on actual ground? Give your answer in kilometers. Now you are using simple proportion using this one. if 1 centimeter is representing 2 kilometers, then 8 centimeters will be representing more or less, it will be representing more. If you want more number according to simple proportion, more number to the numerator, more number, that's 8 over 1 times 2 kilometers. On actual ground, the road is 16 kilometers. As simple as that. Let me present one more question. Suppose number B question is saying a road is 80 kilometers long. Find its length on map. Find its length on map. If a road is 80 kilometers long, on the map in centimeters, find its length on map in centimeters. We still use this scale. If 2 kilometers are represented by 1 centimeter, how about 80 kilometers? 2 kilometers are represented by 1, so 80 kilometers will be represented by more than 1 centimeter. So more number is the numerator, 80 over 2 times 1 centimeter, and we get the answer 40 centimeters. Then sometimes you may be asked to handle problems to do with area, like this question number C. Calculate the actual area. Calculate the actual area in square kilometers of a dam on the map, which is calculate the actual area in square kilometers of a dam. Let's say calculate the actual area in square kilometers of a dam on a map. If it is 4 square centimeters on map, alright. On the map, a dam is 4 square centimeters wide. How about on actual ground in kilometers? Now look, when it comes to area, we are talking about square centimeters, square kilometers. So this scale no longer deserves to be the one that we will be using. So this scale was for length. So when you're dealing with the area, you must square the scale first. 1 centimeter is 2 kilometers. But now on top of area, you give power 2. That is 1 times 1 will remain 1, but it's now square centimeters. Dash 2 times 2 will get you 4. And it's now square kilometers. So this is the scale that we will be using for converting the areas. Then let's handle the question. The question is saying if 1 square centimeter is representing 4 square kilometers, then how about a dam which is 4 square centimeters on map? On the ground, it will be more than 4 square kilometers. So more number here, 4 over 1 times 4, and you get 16 square kilometers. That's how you handle scale problems. So quickly, let me show just one more example. The question will be like this. Scale on map is 1:500,000. Find number A, actual length in kilometers of a rail line 20 centimeters long on map. Scale on the map is 1:500,000, and on that map a rail line is 20 centimeters long. How about its actual length in kilometers? So if they talk about kilometers, it means the scale needs to be adjusted. It was 1 to 500,000. So let's convert this one to kilometers through divided by 100,000. Like this. So now 1 centimeter is representing 5 kilometers. Now let's solve the first question. The first question is talking about length, so this is the scale. If 1 centimeter is representing 5 kilometers, then a rail line which is 20 centimeters will be more than 5 kilometers. That is more number. It's the numerator 20 over 1 times 5 kilometers, and we will get 100 kilometers. The rail line is 100 kilometers long. Then how about area? A farm is 20 square kilometers. Find its area in square centimeters on map. A farm is 20 square kilometers on the actual ground. How about on map? Now when we talk of area, we must square this one. So it must be squared, so that it becomes 1 times 1. 1 square centimeter is representing 5 times 5, 25 square kilometers. Now we can solve the problem. If 25 square kilometers represented by 1 square centimeter, then 20 square kilometers will be less. Then less comes the numerator, 20 over 25 multiplied by 1 square centimeter. And you solve 5 here, 4, 5 into 25, 5. 5 into 4, 7,8. So it's 7,8 square centimeters. That's how you end up scale problem. Sometimes they might give you a bit complicated task, such as this one. You will be given the length on a map. "20 centimeters represents 80 kilometers. Find the scale in the form 1:8. A road on map is 20 centimeters, but on actual ground it is 80 kilometers. So find the scale. Now we are finding the scale. You simply use this given length. 20 centimeters on map is representing 80 kilometers on the ground. But the first thing is, you must make sure that these lengths are of same unit. So we need to convert kilometers to centimeters. We were dividing by 100,000. Now we should multiply by 100,000. So it becomes in centimeter, length in centimeter. 20 centimeters is 80 times 100,000. Then the scale is said you must start by 1. To make 20 a 1, you divide by 20 both sides. So that you get 1 S2 17 102 1 2 4 0 and other 1 2 3 4 zeros 1 2 3 4. So the scale is 1:400,000. That's the scale. So you must divide the ground length by 100,000. That is only if we are talking about centimeters and kilometers. But when we are talking of centimeters and meters, for instance, example number 4, scale on a plan of a building is 1:500. Calculate number A, actual length in meters. 8 centimeters on plan. On a plan of a building, when the plan is like this, on the plan of a building, a scale used is 1:500. As long as the units are not specified, they are both in centimeters. So they are saying 1 centimeter is representing 500 centimeters. Find the actual length in meters of a wall. This time around, we are not talking about kilometers. So which means this one should not be divided by 100,000, but it should be divided by 100 because a meter is 100 centimeters. So let's divide by 100 centimeters. And the scale is 1 centimeter is representing 5 meters. Good. Now we can convert the given question. A wall is 8 centimeters. 8 centimeters will give us more. That is more number 8 over 1 times 5 meters, and we get it 40 meters. The same applies when you are asked to calculate area. You will be squaring this one. For areas, it will be 1 square centimeter, 5 squared, 25 square meters. Then we convert. Check with past exams. Ask, feel free, get in touch with me on WhatsApp on that number. So we talk, we discuss.